Hello everyone, my name is Hardy, and today my topic is hydrogeochemistry and acidic property of submarine groundwater discharge around two coral islands in the southern China Sea. First, we need to know some words. First is total alkalinity. Alkalinity is the capacity of water to resist acidification, and this is the equation. And these two is the main ions. Next is the DIC, dissolved in organic carbon. It means the total amount of inorganic carbon in solution. And this is the equation. And next is carbonate saturation state, omega. The omega means the saturation level of calcium carbonate in seawater. And this is the equation. And when the omega less than 1, calcium carbonate will begin to dissolve. And now we need to know what is submarine groundwater discharge, SGD. First, we need to know what is groundwater. Groundwater is the water under the ground, like spring water and well water. And SGD consists of two parts. First is SFGD. SFGD means submarine fresh groundwater discharge, means the fresh water go into the ocean. It is SFGD. And RSGD means recirculate saline groundwater discharge. It means the saline water go into the ground and recirculate, go back to the ocean. Yeah. And the purpose of this study is to explore the impact of SGD on nearshore biogeochemistry. And there has not so much SGD research in Taiwan to date. And this paper examined the relationship of SGD between two remote coral reef islands. And this is also the first study to examine the effect of the acidic property of SGD water on biogenic spine and shell. And this is the sampling location in Dongsha and Liuqiu. And we sample the water, and the water is for the seawater, SGD water, and spring water and well water. And we analyze this data, pH, TA, DIC, carbonate chemistry, and methane, and nutrients under here. And we all know how to sample the seawater and the rainwater, but how to sample SGD water? First, you need some tools. You need a syringe and a syringe filter and a stainless steel hollow needle and sampling bags. First steps, you need to walk to the beach and walk into the water. And the water level is about to your knee. And you use the needle, sting it into the seabed, and then start to use the syringe to sample the water. And at last, you collect the water and poison the water by this. Yeah, HgCl2. And go back to the lab and analyze. And this study have an experiment on the impact of acidification on biogenic shells. It used the spring water to observe the change of two calcium carbonate changes. It soaked the sea urchin spine and a pteropod shell into the spring water, which omega is 0.96. And it is for the treatment group. And the control group is the normal seawater, and this is the omega. And this is the condition. Yeah. And I want to talk about the major ions in the spring waters of Liuqiu Island. And this is the major cations here. And this is major anions here. And many of them are from chemical weathering of rocks. It will release these ions into the spring water. And this is the raw data of spring water and rainwater. And this is for the spring water data. And these two tables tell us that I transfer transform the ions into the numbers. And the blue one is spring water. Yellow one is rainwater. You can only see the spring water because the rainwater is very low. So it tells us that spring water provides the most major ions. Okay? And next we see these three equations of the carbon chemistry. And our author used table 1 and table 2 data I show you to calculate the TA and DIC. He wants to know the carbonate chemistry and the acidic property of spring water. And this figure is for the TA and DIC. And the red one, blue one, and green one is the calculate. We also calculate the number of it. And at TA, there is some unexplained part. It cannot explain here, yeah. And it used the the table of the spring water data. You can see the PCO2 is really high, and the DIC and TA is high too. But at atmosphere is 400 micro ATM. So he do some calculate to assume PCO2 is when it is 400 micro ATM, same as the atmosphere, and gets this data. And the first is CO2 gas exchange won't affect TA. And calcium carbonate and magnesium carbonate weathering will consume CO2. And organic matter decomposition contribute to CO2 in the groundwater. And last is it explains the excess CO2 part. The soil air has a higher CO2 concentration than the atmosphere, so it will contribute to the groundwater CO2. And the experiments show us that the spring water will dissolve the spine and the shell. At first, we can see the normal seawater. You can see the surface is really smooth. The seawater won't affect on the spine. And the spring water, you can see that this is first day and this is 60 days. The surface becomes rough because the calcium carbonate was dissolved. And the shell is rough, the surface is rough too because it is dissolved. So it shows us that when omega less than 1, it really influences the carbonate shell. Yeah. And next is the data between Dongsha Island and Liuqiu Island. First, we can see the blue one, blue dot is the sea water here, same as these two figures. And the red one is SGD water. You can see red one, red dot. And the green one is groundwater here. And the blue one is rainwater, it's really low. And the spring water is black. Okay, first we see the carbonate chemistry, like TA and DIC. Okay, here and here. You can see they have a correlation with the seawater and the groundwater. And the x-axis is the salinity. So when the salinity becomes high, the TA will become lower, and DIC too, okay, here. And let's see on the nutrient here. When the salinity become higher, so the nutrient will become lower, okay? So the seawater nutrient is lower than the groundwater. Okay, it's really hard to explain. And let's see this figure. This figure shows us that the temperature of the seawater and the groundwater and rainwater and So you can see the higher temperature means the summer, and summer means the wet season. So in the wet season, we can see the SGD water signal. And you can see SGD water signal also in the winter. It is the dry season, okay? And this figure is about DO and pH, and it has positive correlation with the salinity. So salinity higher, the pH and DO is higher, okay? And next is talk about the carbonate chemistry and the nutrients. It shows that negative correlation with the salinity. So, okay, yeah. So the conclusion is, first, the solution of carbonate rocks will increase pH, omega, DIC, and TA. So you can see spring water dissolve the rocks, carbonate rocks. So the TA and DIC become higher. Yeah. And CO2 from organic matter decomposition or soil will enhance groundwater corrosiveness, shifting omega lower. It means it will dissolve the shell. Yeah. SGD is a significant acidic contributor to coastal waters because it will physical mixing with the seawater, so it will influence the coastal water. Okay. And next, although SGD represents a small fraction of river discharge, it is a real common natural phenomenon, and it will impact coastal line all around year, especially in the dry season. And we need to more investigate into SGD to know the impacts. Yeah, thank you.
Hi, Hardy. Can you explain the physical mixing between the groundwater and sea waters? The page that has many figures.
Okay. Here, first we see the DIC and TA is a carbonate chemistry. So I said groundwater will physical mixing, SGD will mixing with the seawater because you can see the R square is on the line, and it will because the SGD will go into the seawater, right? And so they will have the physical mixing.
You say you I want to go to you get a sample that page, the needle, what anything. So you do this sample to collect the SGD, right?
Yeah.
And how you know that the fish there is under the sand has SGD?
Oh, it's a big problem. First, we all know that the water comes from the underground, right? So it called the groundwater, and when it goes into water, go to the seawater, it called SGD, and we will look. If around the beach there's have a spring water or the well water. Do you know spring water? It means a hole that have the normal water, yeah, without salinity, and it usually go into the underground and then go to the nearby the beach, yeah, and go to the seawater. We can see it by the data because if they have SGD, obviously, you will see the salinity not high as the seawater. It's a little bit lower. A little bit. Yeah.
Okay.
Hello, can you turn to page 21? Yes, and I want to know why in that figure, why the red line in that figure go up.
Oh, because you can see the SGD water. It is when the salinity go up, it happened. It show here. It show why it go up because the high salinity SGD water is more here, so it will go up.
And do you know why?
Maybe I think it's just normal. It's not particularly. It's just natural.
Oh.
Yeah.
Oh, okay. Thank you.
I want to ask, does the sea urchin spine in these two in the test is the same? Is same type of the sea spine?
Oh, you said these two spines.
Yes,
Is it the same?
type.
Yeah. Yeah.
Okay.
Yeah.
I just wonder why you choose Xiaoqiu and Dongsha for the experiment. Why you can choose other island like Jinmen or Laiyu?
Because Dongsha and the Liuqiu Island is both the coral island, and we want to compare the SGD between them, and you can see the TA and DIC is really high. We can prove it is because of the coral reef.
Okay, so unfortunately, this is somehow in my expertise, so I will have quite some criticism. Okay, but so first of all, it is very nice, very kind of you to provide a word list. However, usually after the slide, especially if they are not chemists, they will simply forget. So therefore, I don't encourage you to provide a vocabulary explanation at the beginning. It's really not necessary. You do this only when you use the word. Otherwise, you will simply forget. They will simply forget. Okay. Therefore, I would suggest that you should use the introduction to say more about SGD. Here, you already explain what is SGD, but then you go directly to purpose. So for example, like Eric's question, why do you choose these two islands? What is the special thing about these two islands? You should say this in your introduction. Then, here you show purpose. This is a bit too long. You have to shorten it a bit too long. Then, sampling location. You display this really, really fast. You have to keep in mind that not everyone is familiar with this area, so you have to spare some time, take time explaining where they are, okay? Then, this is nice, but this is not that necessary. This is not necessary. I think this is okay. So you can tell the audience how SGD was sampled because this is sort of unusual, very different from seawater and river water. Then, okay, considering the content of your talk, I will actually suggest that you should remove the shell part and then use more time to explain the chemical composition of SGD. I will tell you how. Okay, then, therefore, you can remove the related slides and also the related purpose statement because the discussion on shell is a little bit distracting. Distracting 就是让人分心的 distracting. Then this is not recommended. I simply don't read it. It's really simply not necessary. Okay. Then I think you all realize that in this paper there is a lot of figures like this, where the x-axis is salinity and the y-axis is different parameter. I think you should simply use one specific slide to explain the reason why you have salinity at the x-axis. Why? Okay, for example, when salinity is 0, what is your expectation? And then apparently seawater is at the other end. And then when there are different salinity in between, what they mean, you have to explain the reason of using this kind of graph because it's very typical in marine chemistry. Use one slide. And then regarding this horrible display, my suggestion is as follows. So you have two options. The first option is you never display everything together. Okay, you have to put them into groups. The first option is you put one group, one slide showing simply carbonate chemistry, all carbonate chemistry, and then all nutrients in another slide, and then at the end, parameter other than carbonate chemistry and nutrients, all at the other side. That's one option. The other option is you look for parameters that have positive correlation in one slide, negative correlation in another slide, and no correlation in another slide. And you have to pay attention regarding during the discussion, you were focusing on this. Look at my slide. I think you should talk to your supervisor to know whether this is interpretable. This is statistics. Whether you can say there is correlation or not based on the value here. Okay? So you have to divide them into groups and then discuss them. You describe the pattern, and then afterwards, you provide explanation immediately. Okay, what caused higher DIC in the SGD, or higher TA in the SGD, etc., etc. Okay. And based on that, I think you already have enough material for your presentation. Take time to present your data and provide explanation. Okay, so this should be removed. And this one, you have to think about this because this is a little bit too complicated for them. So you don't need to show this calculation. They don't really care. Okay, all you need to say is, okay, based on some calculation, what is the major source of alkalinity in the SGT, and what is the major source of DIC? That would be good enough. Keep it simple, without so many words. Okay? Good. I hope to see your improvement next time. Okay.